So we're going to look at trial question number 3. Question 3. Now, when we look at trial question number 3, the question reads, the following diagram, figure 3, shows the op-amp setup of a voltage amplifier. The op-amp is powered from a 15-volt power supply. Assume saturation occurs at 15 volts. Calculate the voltage gain of the amplifier. What is the output voltage when an input of alpha 0.2 volts, beta 1.5 volts is applied? And then state 4 characteristics of an ideal operational amplifier. What is common mode rejection ratio? And then there is a question. A certain operational amplifier has an open loop differential voltage gain AD of 50,000 and a common mode gain of 0.4. Determine the common mode rejection ratio. What is the purpose of offset null circuit in the operational amplifier circuit? All right. Now, before I continue to answer these questions for you, I would take just about some 5 minutes to briefly talk about operational amplifiers, okay? Now, operational amplifiers are basically three-dimensional devices consisting of two inputs and an output, okay? When you read from your lecture notes, it says that an operational amplifier is basically a three-terminal device consisting of two high impedance inputs, the inverting and non-inverting input, and an output. A typical op-amp symbol is shown like this. This is a typical op-amp symbol. So you have the output, you have this is the inverting input, the negative side is inverting input, and then the positive side is the non-inverting input. Now, the reason we say one input is inverting and the other input is non-inverting is that for the negative side, assuming you have a positive signal and you subject it to the inverting input, it will change the polarity from positive to negative, okay? And then for the non-inverting side, whatever signal you give to it, it will still come out the same. So basically, operational amplifiers need a minimum of 5 connections, okay? And those 5 connections are the inputs, which is the inverting, the non-inverting, the positive voltage, the negative voltage, and then what? The negative voltage, and then the output, okay? So that is what the connections for an operational amplifier looks like. So an op-amp needs a minimum of 5 connections, as I have drawn here. as well as the 2 inputs and 1 input, there are 2 power supply connections. So this, aside the 2 inputs, this one, and the output, we have what? The power supply connections, and that gives it the minimum of 5 connections, okay? Now, the power supply section in some cases would be labeled as positive VS and negative VS, indicating the IC needs both positive and what? Negative supplies. And in most cases, you will see some op-amp designations. You can see positive 5 volts, positive 15 volts. You see positive plus or minus 5 volts, plus or minus 15 volts, okay? So in the question we have here, what they are basically telling us to do is that there is an op-amp circuit with an input voltage, okay? And I'm going to redraw this diagram. So we have our op-amp with the positive side and then the negative side. Now the positive side is grounded, okay? Now we have the output. Let's term this as V out, okay? Now this input here has a resistor, and coupled with the resistor, there is a supply, okay? Now, there is a feedback system which gives us another resistor, which is looped from the output back into the input. And then we have our positive and negative supplies. So this, from the question, this is 15 volts, and this is what? This is negative 15 volts, and this is positive 15 volts. And we have our R2, which is the same as RF, to be equals to 120 kilo ohms. And we have our R in, and we have our R in to be equals to 5 kilo ohms, okay? Now, I of question 3A is asking us to calculate the voltage gain of the amplifier, okay? Now, if you refer to your notes, in calculating for the voltage gain, you would see that there is a formula, I, voltage gain of amplifier A. You will see this, you would come across a formula which is represented as A equals to RF over what? Rin. Okay? You understand? Hello? Is there anyone here?
Yes, sir.
Are you following what I'm doing?
Yes, sir.
Okay. So in that case, since we have RF which is the same as our R2 to be 120K, 120 times 10 raised to the power 3 ohms. And we have our R in to be equals to 5 times 10 raised to the power 3 ohms. We would then have our voltage gain to be 120 times 10 raised to the power 3, positive 3, times 10 raised to the power 3, all divided by 5 times 10 raised to the power 3. Okay? So now, if someone has a calculator, the person should do the calculation and let's see what we get. Sorry, I omitted something here. The formula is negative RF because it's a feedback loop, okay? And this is a this is an inverting circuit. So it's negative RF, okay? Remember to include a negative when you have such a question or a similar question like this. What do we get?
Negative 24.
So you get negative 24. That is the voltage gain of the amplifier. Okay?
Gain.
Yes, sir.
Now, the other part of the question is asking us to calculate for the output voltage, assuming that we had an input voltage of 0.2 or 1.5. So in order to calculate the output voltage, V out, it's expressed as the gain times V in, okay? So if we are calculating for when our V in, so if V in is equals to 0.2 volts, then it means our V out is going to be equals to minus 24 times 0.2 volts. And that will give us what? I'm waiting for the answer. Multiply minus 24 by 0.2. Okay, yes, Sarah, that is correct. Minus 4.8 volts. So we have minus 4.8 volts. Okay. Now, that is for alpha. Now, for beta, where V in equals to 1.5 volts, it means that our V out will be equals to minus 24 times 1.5 volts. And that will give us what?
That's 36.
All right. So we'll get minus 36 volts. Okay. That is the answer for A. Okay. Now, for B, The B part of the question asks us to state four characteristics of an ideal operational amplifier. Four characteristics of an ideal operational amplifier. Four characteristics of operational amplifier. Now, this has been explained thoroughly in the notes, but I'm not going to go into the explanation now. I'm going to give you only the characteristics, okay? You can refer to the notes and get more information, but the characteristics of an ideal op amp. So, ideal op amp characteristics. One, it has what? An infinite open loop gain. Two, it has an infinite input impedance. Three, it has zero output impedance. And then four, it has infinite bandwidth. Five, it has zero offset voltage. Six, it has infinite CMRR, which represents common mode rejection ratio. Okay, so these are the ideal characteristics of an op amp. Assuming an op amp has it's not subject to any other conditions in its ideal state, it's in its normal state. These are the characteristics it should exhibit. Okay? So take note of that in case you are asked to state some characteristics of an ideal operational amplifier. You are expected to choose from this list. It is not in any order. You can decide to state number 6 first. You can decide to state number 3 first. Any of them, however you choose to arrange it. They are not in any order. Okay? Are we there? Okay. So now I know one question will be in your mind you would want to ask is that, sir, what is CMRR? or what is common mode rejection ratio? That is the next question. And that is the C part of the question. It states that what is common mode rejection ratio? In simple terms, common mode rejection ratio is the measure of the operational amplifier's ability to reject common mode signals. Okay? CMRR is the measure of the ability of the op amp to reject common mode voltages. Okay? That is the simple definition. Now, mathematically, it is the ratio of the differential gain to the common mode gain. So, mathematically, it is the ratio of the differential gain, which is represented in most cases by AV into bracket small d to the common mode gain. Into brackets, it's also represented as ACM. That is the common mode gain. So in some books or in some places, you will see CMRR to be equals to AVD divided by ACM. Okay? Now, assuming you are asked to define common mode rejection ratio, you can go ahead and state just this and explain the various or state the meaning of the various components here, the numerator and then the denominator. But when you are asked what is CMRR, then you would have to write and explain what CMRR is, or common mode rejection ratio is. And then you can add the formula if you so wish to explain. But if you are able to explain, as I have underlined here, in your own words, but to capture the importance of what you want to communicate, it is acceptable, okay? Is there any question or I should continue?
Continue.
Are you saying I should continue?
Yes, sir.
Yes.
Okay. All right. So let's move on. Let's move on to the next question, which is CI. Now, before I continue, can someone tell me what they notice about the way I have set these trial questions with respect to your notes? Can someone tell me something? What have you noticed? If you want to
What
talk,
you are teaching now is simplified.
you said?
What you are teaching this evening, or what you are teaching online, is simplified as compared to what we have.
In the notes.
Yes, please.
Okay, but the idea for setting the questions or the trial questions this way was to guide you to read your notes. Okay. So when you
Okay.
take each of the questions that covers each particular chapter, you realize that it takes the chapter chronologically. Once you move from one area, you move to the next one, and then it gives meaning to what you did earlier on. So once I'm done, just take your time and go through it, and I'm sure you guys would be able to pass your exam successfully. Okay?
Okay, sir.
All right. So the question here is that a certain operational amplifier has an open loop differential gain of 15,000. So that means that open loop differential gain, which is AVD, is equals to what? You can decide to make it AVD or
Okay.
AD. Anyhow you do it, and you just anyhow you write it, because different books and how they write it. In some books, you will see A subscript V into brackets D. In some books, you would see A subscript D. I will mark you down if you write any of this, but when you write them, you should be able to annotate that this is what they mean, so that when I'm using them or when I'm referring to your script or whatever material you are presenting, I would understand that this is what this is standing for. Do you understand?
Yes, sir.
Okay, so let's move on. So our AVD here is 15,000. Okay, and then there is a common mode gain, which is ACM of 0.4. Now we are being asked to calculate for CMRR, which is common mode rejection ratio. It says determine the common mode rejection ratio in decibels. In decibels. Now the formula here is not in decibels. This formula you see here is not in decibels. However, if we use the formula to do our calculation, there is a way we can convert it into decibels, okay? So don't panic. So here we have our CMRR, which is the common mode rejection ratio, to be equals to AVD divided by ACM,
Okay.
which is equals to 15,000 divided by
So,
0.4. Okay, what do we get? Can someone help us?
37,500.
37,500.
Yes, please.
Okay. 37,500. That is what we got for our common mode rejection ratio. Okay. Now we have been asked to calculate it in what? In decibels. So if we are going to calculate it in decibels, then CMRR is going to be 20 log into bracket what we got, okay? So you can decide to make this CMRR subscript decibels or CMRR in decibels equals to 20 log CMRR, okay? Which is equals to 20 log. Now, when I write log like this, what does it mean? To what base is that? When you see just log, to what base is that logarithm? Hello?
Hello.
Yes. When you see someone write just log like this, what is the base of the log?
Base 10.
Exactly. So it is base 10. So you can choose to bring your base 10 or you can leave it. Okay. So in that
Alright.
case, your 37,500, and then someone should compute this for us.
One point 4.8.
What?
1.57. 1.57.
Are you sure?
Yes, sir.
Are you sure you did your logarithm well? 20 times log
Alright. Okay.
37,500.
That's 91.48.
Yeah.
Yes. So, like I said earlier on, always leave your answers in two decimal places. So it is 91.48
8.
dB. Okay, that is decibel. Okay,
Alright.
Okay.
so that is the answer. Now, the last question is asking us to the last question is asking us what is the purpose of offset null circuit in operational amplifiers? It is very simple. Okay, the answer is simply cancel the effect of common mode gain. Okay, are we okay?
Yes,
Yes,
sir.
please.
All right, so this brings us to the end of the solution for tutorial question 3. So that is what it is. Now it is left with one question, and that question is not very difficult. It is just a bit trickish. It's not difficult. We will solve the part A. The part B is basically the same as what we have just done, okay? So let me end this video as well.